Hi, welcome to this STAIR Tailored. I'm Sarah Powell from the University of Texas at Austin, and today we're focusing on ordering fractions using the set model. Now, the set model means that we can take objects and make a set of those objects, and some of the objects in that set can represent the numerator of the fraction. So we are going to use the two-color counters today. That's a really good example of the set model, and we're going to use those two-color counters to compare these three fractions: 3/4, 1/3, and 5/8. So let's see what this looks like. So I'm comparing the fractions 3/4, 1/3, and 5/8. So I have those written here on my sticky notes, and I'm going to move those sticky notes around as I figure out which fraction is least and which fraction is greatest. So first I'm going to show the fraction 3/4. So that means I'm going to show a set with 4 equal parts, and I'm going to show 3 of those 4 parts. I'm also going to show the fraction 1/3. So that means I show a set with 3 equal parts, and I'm going to show one of those parts. And then I'm also going to show a fraction with 8 equal parts. Alrighty, we'll get all my 8 counters here. And then I'm going to show 5 of those as red. So we got the fraction 5/8. Now here's a thing that's a little bit tricky. If we set these fractions up just like this, students might say that 1/3 is the least, 3/4 comes next, and 5/8 is the greatest, because I see 1 red counter, 3 red counters, and 5 red counters. The thing that we really need to emphasize here is that we can't compare these fractions right now because these fractions do not have the same value. These counters don't have the same value. That's what I mean. So here I'm going to have to find some common denominators to help me compare with the set model. Now, I could write out the multiples here, and I'm just going to go ahead and write this on my page here. So the first 5 multiples of 4, 4, 8, 12, 16, and 20. The first 5 multiples of 3, 3, 6, 9, 12, and 15. And the first 5 multiples of 8, 8, 16, 24, 32, and 40. All right. Now, if I'm comparing these fractions here, I could see that I still do not have a least common multiple when I'm thinking about this fraction with a denominator of 3. But what is really important when you're ordering fractions is for students to understand where fractions fall compared to a benchmark fraction. The most common benchmark fraction is 1/2. Now, if I'm looking at these fractions, I can see that 3/4 is greater than 1/2, 5/8 is greater than 1/2, and 1/3 is less than 1/2. So automatically, I should move 1/3 here. It's going to be our fraction that has the least value. And then I don't really have to think about this 1/3 much more. I'm just going to move it over here because I don't need to think about that. I could actually work on finding a common denominator with thirds. It's going to end up being a pretty great common denominator, and I don't want to get that many counters out because I already know that 1/3 is less than 1/2. Now I got to discriminate between the fraction with a denominator of 4 and the fraction with a denominator of 8. Here, the least common multiple with these two fractions is 8. So I have a fraction with a denominator of 8, so I'm going to leave 5/8 as it is. And to make 3/4 into a fraction with a denominator of 8, I'm going to iterate that set 1 time. Iteration means making a copy of the set. So here I will copy that set 1 time. So 1 time, I need to make a copy. And now it's very easy to see that 3/4 is equivalent to 6/8. Now, if I want to line these up to make this a little bit visually easier, I can take my 6/8 and show it right here. And now I can compare, and I can see that 5/8 is less than 3/4. So I'm going to move my sticky notes around one more time so that if I'm ordering these fractions, 1/3 is less than 5/8, and 5/8 is less than 3/4. Now that was an example with the set model. I hope you'll look at some of our other STAIR tailors. I'll get to our last page right there. I hope you'll look at some of our other STAIR tailors where you can see how we can compare fractions using the area model and how we can compare fractions using the length model. See you soon.